Hi, this is Vidya Rani, working as Assistant Professor, Department of ECE, Annamacharya Institute of Technology and Sciences. In this video, I am going to explain some types of communication systems. In this, we are going to cover different types of communication systems. Basically, communication means transferring information from one place to another place through a communication medium or through some communication link. Previously, we can say that in earlier days, communication is very poor. It's become a major problem for communication. Why means in previous days we communicate through birds like pigeons, sparrows, and then later on letters, and these letters are carried out by some animals. After the invention of the automobiles, then it is carried out through the um, like postcards. These are the some means of communication in the earlier days. But through the technology development, it brings a great change in the communication field. Now we are using social network platforms, this type of video lectures. These are the fruits of the invention of technology that we are using it now. So basically, there's a major breakthrough in communication leads with satellite communication, and we have different modes of communication based on the requirements. Those are, for examples, we can see that a microwave communication using microwave frequencies, television broadcasting, telephony and telegraphy, radio communication, satellite communication. These are some of the examples, or we can see that these are some of the examples of a communication system. In this lecture video, I'm going to explain this microwave, satellite, fiber optic, TV, and mobile communication through its block diagram approach. In this video, I'm giving to brief out the each communication system, how the transmitting and receiving is possible in this communication, and its application fields. So first we will discuss microwave communication. Microwaves are nothing but high frequency signals and whose range is in the order of gigahertz, whose range is 30 from 30 hertz to 30 gigahertz to 300 gigahertz is the range of microwaves. Why this microwaves are needed means because this radio frequency ranges are congested due to different frequency spectrum. Frequency spectrum is nothing but band of frequencies, and a small portion of a spectrum is nothing but a channel. So because of congested channels in the spectrum, it becomes problem for the radio communication and for transmitting high information signals, which requires a wide bandwidth, the information which is very long. So to solve these issues, microwaves or microwave frequencies are used. These microwave frequencies are high frequencies, and it will be helpful for the long distance communication. It has a very major role in many industries or many applications it has. So majorly it has a radar gauging, ranging the foreign objects which are entering into our country for security and surveillance purpose. And in TV broadcasting, TV needs more than 6 gigahertz range frequencies. In the TV spectrum also, TV range of communication also, microwave frequencies are used. And for long distance telephone communication, and like for heating uh, food items like snacks and all through microovens. There in microovens also, these microwaves are also used, and in medical field for diathermy applications for healing the wounds, this microwave frequencies are used. This is some brief about microwave communication. And next type of communication is satellite communication. So you all know, aware about satellites, and the upcoming adventures regarding the satellites. So what is the base for this satellite communication? What is a satellite? How it is developed? How the communication is developed to this satellites? We will see now. Satellite is basically of two types: natural and artificial satellites. So basically, a satellite means a physical or celestial body which is revolving around the Earth. It's nothing but a artificial satellite. We all know that natural satellites are moon is the natural satellite for earth, and planets, 9 planets which are revolving around the sun in the solar system are also satellites for a sun. So like this we'll have different types of natural satellites. Artificial satellites are nothing but the satellites which are revolving around the earth in its fixed find objects. It's nothing but a artificial satellite. So look at this picture. Look at this picture. This is the earth and whose direction is from like this, and satellite which is defined to revolve in the fixed orbit is this is the satellite, and and this is the direction of its movement, and this is the orbit in which it is revolving around the earth. This is the a simple artificial satellite which is revolving around the earth in its fixed orbit. This is nothing but a artificial satellite. And how this satellite communication is possible, we will see. So, as I discussed, a satellite which is revolving around the Earth in its fixed orbit is nothing but a satellite. For Earth, and the distance between the Earth and the satellite, the mean distance is 36,000 kilometers. The satellite that orbit directly over the equator at a height of 36,000 kilometers with a traveling speed of 11,000 kilometers per hour is said to be a geostationary orbit or geosynchronous satellites. We all know that our prescribed space station ISRO or SHARE is sending the satellites using the GSLV and PSLV vehicles. GSLV is nothing but geosynchronous space launching vehicle, and PSLV is nothing but polar satellite launch vehicle. So those GSLV satellites or rockets are based on the geosynchronous orbits. So based on this geosynchronous orbits, the inventions are made through this orbiting through the geosynchronous orbit. Geosynchronous orbit is nothing but it is at a height of 36,000 kilometers and have a traveling speed of 11,000 kilometers per hour. The type of orbits are nothing but geostationary orbits. And this communication satellites works as a relay station, means it will have some transmitting station and receiving station. So for this transmitting and receiving, the signal will have two types, two types of frequencies. What is uplink and one is downlink. Uplink means transmission of signal from ground station to the satellite. From ground station to the satellite is nothing but downlink. Sorry, uplink. Downlink means receiving the signal from the satellite to the ground station is nothing but a downlink. These are the two frequencies while transmitting and receiving from satellite takes place. The combination of transmission and receiving is called transponder in a satellite. So the transmission and receiving section in a satellite is nothing but a satellite transponder, whose role is to amplify the signal before it is transmitted back to the earth station. So the figure which you are looking on the screen is the satellite transponder. This is the satellite transponder. It will have a receiving and transmitting antenna. For receiving and transmission, same antenna is used because transmission and receiving frequencies are different. That's why we can use single antenna for transmitting and receiving. And this is the RF front end receiver, carrier processing equipment, power amplifier. We will see what is the use of these blocks and a satellite transponder. What is a diplexer means? It will receives the uplink transmission information and retransmits the signal through its downlink mechanism. This is a function of the diplexer and a satellite transponder. Then the received signal from the antenna is passed through the diplexer first through the RF end receiver. What this RF end receiver will do means the signal which is received from the antenna is of low power, so to increase its power and voltage levels, this RF front end receiver is used, means it will increase the signal to noise ratio of the signal and provides proper amplification. And then it is fed to the carrier processing unit. This carrier processing units involves demodulation and remodulation of the signals. Why this demodulation and remodulation is used means the uplink frequencies are demodulated and downlink frequencies are remodulated, and then it is fed to the power amplifier. This power amplifier increases the power levels of the signal and before reaching the earth station, means it will increase the power levels of the information signal and it can reach the earth station through the antenna in the satellite transponder. What happens? A signal is transmitted from the satellite transponder. How it affects the earth station and what is the process taken place in the earth station while receiving the signal from the satellite transponder. So, and this is the simplified block diagram of a satellite earth station. This is present in the earth and the satellite transponder is present in the satellite. In that also transmitting and receiving ends are present. Through diplexer we'll have to using one antenna only we can transmit the signal and receive the signal in a satellite. So what is the process happens in the earth station we will see now. So this is the block diagram of a earth station. This end is this first end of this block diagram is the transmitting section in the earth station and this is the receiving section in the earth station. Using the same antenna we can recept and transmit the signal from earth station. So first, what is the process involved in this? We will see. It will have in transmitting section encoder, modulator, up converter, high power amplifier, and it is fed to the polarized diplexer. And after receiving the signal, in receiving section, you'll have low noise amplifier, down converter, demodulator, decoder. So we will see how this process is taken place. First, the signal which is transmitted from the satellite or the signal which is to be transmitted is fed as input to the encoder. This encoder will encrypt the information signal and it is fed to the modulator section. Modulator adds the carrier frequency, that thing but high frequency carrier signal to the original information signal and it is fed to the up converter. What this up converter will do means it will convert our information signal or our modulated signal to the need of the uplink frequency. It will matches the uplink frequency or it will converts to the uplink frequency. Then it is fed to the high power amplifier to increase the power levels of the transmitted signal. And then it is fed to the polarized diplexer. Here by matching the uplink frequencies of the satellite, it is transmitted to the satellite end through this same antenna. So in receiver section, if satellite transmits the signal from its transmitting section. After receiving that signal from the same antenna, it will senses its amplifier or if any noises are there through this low noise amplifier and it converts to the downlink frequency. It demodulates and decrypts the original information signal and the original information signal is retrieved at this receiving end. This is the process involved in the satellite earth station transmission and reception. These are the some points related to that. So we will see this all under discussed. Encoder converts the informational signal into a format ready for modulation, means it will encrypt the data and this modulated frequency is then converted to the uplink frequency of the satellite which is then passed to the polarized diplexer of the antenna, and in the receiving section, same antenna of different frequency receives that information, and it undergoes the demodulation decoding section, and the original signal is retrieved at its end. So this is the brief about satellite communication. It will have satellite transponder and a earth station. These two are communicating for establishing a communication using satellites. In satellites, we'll have transponder in that receiving and transmission section, and in earth station also we'll have transmission and receptions, nothing but transmission and receiving ends. This is some brief about the satellite communication. Now next type of communication is fiber optic communication. So till now the communication systems we have discussed is using electrical signals, or some by means of some large carrier frequencies, or some using high range of frequencies we have communicated through the satellite and microwave frequencies, but still we can communicate using light waves also. So how this communication using light waves are established means using a special cable, nothing but fiber optic cable. That's why the communication is nothing but named as fiber optic communication. And this fiber optic communication, we will use the fiber optic cable. What is a fiber optic cable means? It has two ends, sending end and a receiver end. So it is very narrow, and thickness is just as thin as our human hair. So one at one end it will have some receiving end, and other end it will have sending end. So what is the process involved in this fiber optic communication means? Look at this picture on this. Information signal which is needed to be transmitted is first converted, or using this coder or converter section, the information signal is first converted to a digital pulses, and this digital pulses. So we have mentioned that the fiber optic cable is used for transmitting the signal using a light waves. So we need to convert our digital pulses into light beams. So to convert this digital pulses into light beams, we can use high high power sources or light sources. Those are LEDs, lasers, these and all we can use to convert this digital pulses into light beams. At this uh, receiving end of this, sorry, at the sending end of this fiber optic cable, this is the fiber optic cable which is as thin as our human hair. So at this receiving end, we are sending our light pulses which are converted using the LEDs or lasers. These light pulses are traveling through this fiber optic cable, and then at this receiving end we are connecting a photodiodes, avalanche photodiodes. Why means here through this cable we are converting the light pulses, while if we want to retrieve that information which are involved in light pulses, we need to again convert that light pulses into electrical signals to retrieve the original information. For that we are using this photo cells or photodiodes, we can say, based on this and this photodiodes are forward biased, because in forward bias only they can convert the one form of energy to other form of energy. So these are photodiodes. That's why photo means light. So it will convert the light energy into electrical signals. Similarly, LEDs also. LEDs or lasers also, they will convert the light energy, sorry, electrical energy into light energy. So that's why for converting digital pulses to light waves, we are using LEDs and lasers. So after converting the digital pulses to light waves, we are sending that information in the form of light pulses or light beams through a fiber optic cable, while transmitting at the ending, or nothing we can say at the receiving end of the fiber optic cable, we are connecting a avalanche photodiodes. Those are high light sources. So using that we are again converting that light beams or light pulses into a electrical energy, electrical signals. Those are fed to the amplifier. You may get doubt that why need to amplify this electrical signals which are converted from the light sources. Means while traveling through this fiber optic cable, there may be a loss of light energy. Maybe we can lose some portion of the signal, or might be unwanted losses, attenuations are taken place through this movement, or through this traveling through the fiber optic cable. That's why the light pulses which are converted into electrical signals are again amplified using this amplifier, and then it is reshaped and decoded so that we can receive this signals, original information signals. Through this fiber optic cable, we can transmit either voice signals or video signals. So this is all brief about the fiber optic communication. Fiber optic communication means using fiber optic cable, nothing but a special cable. We can like we will transfer the information from one place to another place using the cable networks. And the converter or coder portion is to, because the informational signal which might be analog data or a voice data need to be converted to digital pulses. That's why we are using A to D converters to convert that information signal. It might be a voice signal into a digital signal. And at the end of the sending end of the optical fiber, we will use a powerful light sources which will on and off the light beams continuously, so that light source can generated at the light emitting diodes or lasers, and we will transfer this information through the fiber optic cable for long distance communications. And at the receiving end, by using avalanche photodiodes, we will convert that light source into electrical signal, and this signal undergoes the process of amplification, decoding, and then finally original signal is retrieved at the receiving end. This is all about fiber optic communication. Now we will move on to the next classification, that is mobile classification. So you all may aware about what is a mobile, how that mobile occupies the place in our day-to-day life. So what is the base behind this mobiles? So the emerging technologies and cellular networks enhances the possibilities of learning, improving the knowledge, sharing the data, or communication. We can see that even the people who are very far our place, we can communicate using mobiles and satellite communication. So what is the process involved in this mobile communication? So being the mobile telephone system, it is a very complex networks, communication networks are involved in mobile telephone system and in computer controlled switching networks. To solve this problem, these mobile networks complexities arised in mobile networks are resolved using cellular telephone systems. The basic principle behind this cellular telephone system is that it will divide the geographical area into a small cubes, small hexagonal cubes. Those can be fit and look like a honeycomb cell pattern. This is how the picture represents. Here the small geographical areas are divided into a hexagonal parts, and this based on this users, based on the requirements, these geographical areas are divided, and in this each geographical area we will have a transmitter. This is the inner view of this each hexagonal cell in a honeycomb cell pattern. So this is the transmitter, or this is the cell occupying a hexagonal geographical area on this honeycomb pattern. And the allocation of this cells are based on the frequency reuse planning. Means we can use the same frequency for a different like we will use that the same frequency for different applications or for different users at a time. This is the basic concept behind this mobile communication. Means it will divide that geographical area into a hexagonal shaped cells that can fit in together to form a honeycomb cell pattern. And the concept behind this is frequency reduce. Means we can use the same frequencies for different ranges, and this is a picture which represents the honeycomb cell pattern, and thus each cell is this is the broad view of the each cell, and this will have a transmitter, and it occupies the hexagonal geographical area, and these geographical areas or hexagonal geographical areas are divided based on the users and based on the using of frequencies or using of channels. Now look at this picture. This is a simplified cellular telephone system which includes the PSTN. This is nothing but telephone exchange, public switching telephone network, and will have telephone subscribers. This is the wide communication, and these are the cell sites, nothing but hexagonal cell areas. In each hexagonal geographical areas, we are fitting some transmitters, nothing but towers, and through these towers each individual telephone or mobile telephone switching offices are connected. From this MTSO, this receiving and transmitting sections are converted or connected to the each tower stations in each geographical area, and using common channel signaling system number 7, we will communicate this wide networks. We will see some of the points related to this simplified cellular telephone system. And this cellular telephone system basically has 6 essential networks. Those are electronic switching center. What this electronic switching center will do means, it is a digital exchange located at the mobile telephone switching office, nothing but MTSO. This is the MTSO, and this electronic switching center is available. It is a digital exchange. What it will do means, it controls the switching between mobile to mobile, mobile to mobile, mobile to wide wireless sets, mobile to mobile. It will controls that communication between this mobiles. Next one is base station or cell site controller. This is a base station or cell site controller, nothing but this tower. So what it will do means, it will turns on and off the transmitter and receiver. It will manages the radio channels and performs testing on this cell equipment. This is the functioning of the base station or the cell center. Then next one is radio transmitter and receiver. Commonly it is called as a transceivers. So using common antenna only, we can transmit and receive the data on this radio transmitter and receiver. Next one is system interconnections. These are the system interconnections. What it will do means, it will provide the interconnections between MTSO, nothing but mobile telephone switching office, and each cell sites located in the hexagonal geographical areas, and to the PSTN, nothing but a public switching telephone network. This system interconnections provides the connectivity between the MTSO, PSTN, and the cell sites in this cellular telephone system. And next one is mobile telephone units. These mobile telephone units are individual mobiles or telephones which an individual can carry. In that mobile units, a control unit is present. It will controls the receiving and transmitting in the individual mobiles. And using this communication protocols, we are developing the communication is developed through wireless communication. These are the essential features that a cellular network consists, and the emerging generations in this are we have now we are in 4G technology. Even in other countries, it is emerged to 5G and 6G, and we'll have different multiple accessing techniques like FDMA, SDMA, TDMA. Those are time division multiple access, code division multiple access, and using a SIM, nothing but subscriber identity module. This communication is established between different mobiles and telephones through wide and wireless networks. And these are the some topics or how a cellular network looks like. So these are the some key points related to that. Now we are moving to the next type of communication, that is television communication. So you all know that in TV we can see both the picture and we can hear the voice from it. So what is a property or what is a functioning behind that, we will see. And this television system, it will transmit a picture or a screen or a scene along with the sound to a distance place. Means both picture and sound travels for long distances, and this picture signal is generated by a TV camera and the sound signal is generated by a microphone, and it will have two parts: TV transmitter and TV receiver. And this is the block diagram for the TV transmitter. What it will do means the picture signal or the video signal which is provided from the TV camera is amplified using video amplifier, and it is amplitude modulated using this amplitude modulated amplifier. This TV camera and the picture tube must be synchronized always. Means the pulses which are traveling or the process which is taken place here must be synchronized with the TV camera and the TV camera and the picture tube. Then this amplitude modulated signal is fed to the power amplifier stage. Here, using this local oscillator, it will generate a high frequency carrier signal, and this RF amplifier will select the desired radio frequency signals, and it is fed to the diplexer. Means in diplexer we will have both transmitter and receivers. Means it will combine both the picture and the sound signal. So this is the process for the picture signal. Means this picture video signal is generated by the TV camera and it is amplified using video amplifier. Then it is amplitude modulated. This amplitude modulated signal generated by the picture tube and the TV camera, nothing but a picture signal generated by the TV camera, must be synchronized with each other. Then using the local oscillator, we will add the high frequency carrier and selects the desired radio frequency signal, which is then fed to the power amplifier, which increases the power levels of the video signal, and fed to the diplexer. In this diplexer network, what will happen means this generated video signal and the generated audio signal is combined. But it's a process behind this sound signal is this first voice signal is generated to the microphone and it is fed to the audio amplifier. Audio amplifier means it will increase the voltage levels of the sound signal, and it is frequency modulated using FM amplifiers, and it will increases the sound levels using the FM sound transmitter, and fed this frequency modulated sound signal is fed to the diplexer. So observe one point here: picture signal is a amplitude modulated signal and sound signal is a frequency modulated signal. These two means we need to transmit both sound signal and picture signal at a time. That's why they both need to be combined and should be transmitted. So using this antenna, we are transmitting that combined video signal and sound signal from this TV transmitter. This is how the TV transmitter works. These are the different functioning blocks present in the TV transmitter. First, a picture signal is generated through a TV camera, and then it is video is amplified using video amplifier, and it is amplitude modulated, and power levels are increased using this power amplifier by adding the high frequency carrier signal generated using the local oscillators, and radio amplifier will select the proper radio frequencies, and it is fed to the diplexer. Similarly, from microphone, sound signals are generated. They are amplified using audio amplifiers and frequency modulated using frequency modulators, modulating amplifiers, and these two amplitude modulated and frequency modulated signals are combined in a diplexer, and those are gets transmitted from the transmitting antenna. This is a process involved in the transmitting section. Now we will see what happens at the receiving section. This is the points related to that. Moving on to the TV receiver. Receiver, we all know that receives the transmitter information. Though, so this electromagnetic waves, nothing but transmitted signals from the transmission section, are received through these blocks, and it undergoes this process and reaches the receiving section, or we will retrieve the information at the receiving section. So we will see what is the process involved in this. So this receiving antenna receives that electromagnetic waves generated by the TV transmitter. Then, and here the power levels of the received signal is less because it is traveling through long distances. So to avoid that, you are tuning that information signal, tuning the transmitted signal, and here intermediate frequencies are generated through mixer. Means we will mix the original information signal and locally generated high frequency signal at the mixer end, and it is fed to the video IF amplifier. Here it is it increases the, or it will generate the intermediate frequency signals for videos, and here video detector will detects, or we can say that it will isolates the video signal and sound signal at this video detector stage. So sound signal is fed to the sound amplifier and video signals are fed to the video amplifier. First we will see what happens in the sound signal process. So here video detector will detect or will isolates the video signal and like sound signals. So sound signals are fed with the sound IF amplifiers, and here through FM detector or demodulator, means that modulated frequency modulated signal is demodulated here using FM demodulator, or more precisely we can see that sound FM detector or demodulator will demodulate that modulated signal and fed to the audio amplifier to increase the voltage levels, and it drives the loudspeaker end. Means we can hear the voice which is transmitted from the transmission section. This is a process involved in detecting the sound signals. Then we will move for video signals. So from this video detector we will isolate that video signal fed to the video amplifier. Means it will increases the quality of the video or increases the and it amplifies the video. And here we already know that the picture tube and video signal must be synchronized with each other. That's why we have synchronizing and scanning section in receiver end also. Then it is fed to the picture tube, so we can hear the sound and watch the video at a time in this TV receiver. This is a process involved in it. These are the points. At receiving and a receiving antenna intercepts that or receives that radiated RF signals, or a tuned circuit selects the desired channel signals of particular frequency. Video detector isolates that video and audio signals. So those are amplified using video signals, and sound signals are frequency modulated by the audio amplifiers. Finally, we can watch that video or the picture tube and you can hear the sound signal at the loudspeaker end. This is all about the TV communication. So if you have any doubts, you can browse the net or watch the video again and again. Hope you understand this session. Now I would like to conclude this. So these are the modern emerging technologies which will takes place in the communication systems, communication process. So emerging of these technologies increases the possibilities of communication. So if we use that in the right way, we can utilize the fruitful results of this communication. I hope you understand this session. This is all about this lecture. Thank you.